Hello guys, welcome back. We will be now analyzing the time complexity from the loops in programming. So it's just the continuation of the asymptotic notations which we covered in the previous video. If you haven't checked it out, then please check it so that you can move ahead with this video. Okay, so let's get started. And yeah, so here analysis of loops is the topic in which we will be determining the time complexity by just seeing the loop. So for order of one time complexity, mm, there is no loop. If there is no loop in the function, then you can say that for that algorithm, order of one complexity is there, time complexity is there. This is also to keep in mind that this is big of 1, so we are considering the worst case. And yeah, here its example is given that the swap function, where we just swap the values of the two variables, it's of order of 1 time complexity, big of 1. So for big of n, if there are n iterations for every big of 1 expression time complexity, so we will be having big of n. That means if the for loop runs for n number of times for any order of 1 operation, so the time complexity for that algorithm will be order of n. So here one for loop can be defined in such a way. Also this for loop will also give us big of n time complexity. Now coming to big of n to the power any constant, so it can be n cube, n to the power 4, n square, etc. So it will be considered according to the number of for loops. So let's say each for loop is incrementing by some amount of c, and runs for an amount of time, or decremented by c and runs for an amount of time. Then for that we can say that its order is big of n to the power c, where c will be this increment or decrementing constant. Now coming to order of log n, so for this if we multiply our constant with the the incrementing by some multiplication constant, then our algorithms complexity will be order of big of log n. So basically if I sometimes say that it's order of log n or big of log n, don't be get confused, because these both are same. And sometimes it's people call it as order of log n or big of log n. So yeah, both are valid, because in general we consider the worst case only, and people understand from that. So yeah, this will give us log of n complexity, and either multiplicating or dividing by some constant, like decreasing the loop or incrementing the loop. Now coming to, let's say, the order of log n, log n, sorry, not log n is different thing, log of log n. So here log of log n will be there when we increment our ith iterator with any power. c, or we consider a function I where it can be cube root or square root. In such case, order of log n will be the time complexity. So let's combine these and let's check from this example that what will be the answer. So let's say the algorithm has two for loops. Those are not inside one another and are different. So basically, as it is incrementing, so it will be order of m for here and order of n for here. So uh, and these both are not into each other, so we will not multiply these and we will add this. So at last, order of m plus order of n will be the time complexity for this code, which can also be written as order of m plus n. And if m is equals to n, then time complexity will become order of 2n, which we can write as order of n because we are actually considering the asymptotic analysis time complexity. So these were just the cases, and if let's say there are many if else statements, then the in that case we need to evaluate such that maximum number of statements are executed, the if else conditions. So in the linear search, as I mentioned in the first video, we have to only check once one if statement in that loop. So that will be, we have to consider only one order of one. Hence it depends and we have to actually check. And for recursive functions, there is a master algorithm or master theorem, you can say, and that is actually used to find the time complexity, which we will see later on. And you can also check out this quiz on analysis of algorithms if you are somewhat at an advanced level and you know some algorithms. So yeah, this was it for this video, and in the next video we will be checking some amortized analysis introduction. So stay tuned and keep learning.